projects. In this video, we are going to explain about a project titled Plant Leaf Disease Detection and Classification using Deep and Machine Learning. The agriculture sector faces notable productivity setbacks and substantial economic decline due to the plant diseases. Timely identification and precise categorization of the leaf diseases stand as a pivotal factor in proficient disease control. The evolution of deep learning and the machine learning methodologies has sparked a search to pursuit of automated systems dedicated to detecting and classifying the plant leaf disease. This study seeks to delve into the implementation of these cutting-edge technologies to achieve the meticulous and streamlined detection and the classification of plant leaf disease, marking a stride forward in the disease management strategy. The primary aim of this project is to construct a resilient and dependable system for detecting and categorizing the plant leaf disease through the utilization of the deep learning and the machine learning algorithm. The specific objective encompasses the various stages: initial collection of diverse dataset encompassing of both the healthy and the disease-affected plant leaf images, meticulous reprocessing and the augmentation of the dataset to ensure it's appropriate for the model training and the testing, exploration of advanced techniques of different deep learning models to extract the pertinent features from the leaf images, subsequent training of the deep learning and the machine learning model with the refined dataset to grasp the distant disease-related pattern, establishment of proficient classification mechanism capable of accurately identifying the specific disease present in a given leaf image, comprehensive evaluation of model performance using the metric like accuracy, precision, recall, and F1 score, real-world validation by testing the system on actual leaf images to gauge its practical viability and the resilience, and lastly, its analysis between the efficiency of deep learning and the machine learning model to determine the superior approach for precise plant leaf disease detection. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the package. And this stage, the necessary libraries and packages are imported, encompassing the tools like of data manipulation, visualization, and the machine learning. And the next step is exploring the dataset. In this phase, the dataset containing the plant leaf images is loaded and explored. Exploratory data analysis techniques are applied to understand the data structure, size, and the distribution. And the next step is image processing. Image processing techniques are employed to enhance the quality of the leaf image. This involves operations like resizing, cropping, and the noise reduction to prepare the image for the feature extraction and the model training. And the next step is data extraction. The data extraction step involves isolating the relevant feature from the images. This includes the extracting the color histogram, textures using the pre-trained deep learning model to extract the high-level feature. And the next step is splitting the data into the train and the test set. The data set is divided into the training and the testing subset. The training set is used to teach the model to recognize the pattern, while the testing set assesses how well the model generalizes the new unseen data. And the next one is building the model. Here various models are built. The first one is Inception V3. It is a deep convolutional neural network architecture that has shown remarkable performance in the image classification task. It employs a combination of convolutional layer with various filter size to capture the feature at the different scales. And the next one is MobileNet. It is designed to be a lightweight and efficient, making it suitable for the resource-constrained environment like of mobile devices. It employs depth-wise separable convolution to reduce the computational load while maintaining the reasonable accuracy. And the next one is VGG19. It is widely recognized deep neural network architecture characterized by its uniform architecture of stacked convolutional layer. It excels at learning and representing the complex pattern and the images. In this project, BGG19 captured the intricate details from the plant leaf images, contributing to the disease detection and the classification. And the next one is DenseNet 121. It introduced the dense connection between the layers, allowing each layer to receive the feature map from all the preceding layer. This design facilitates the feature reuse and the information flow across the network. In this project, it efficiently captured the feature from the plant leaf image and contribute to the accurate disease classification. And the next one is Inception ResNet V2. It combined the Inception architecture with the ResNet residual connection. This hybrid architecture aimed to harness the strength of both the designs for the improved feature extraction and the representation. And the next one is ResNet 152v2. It is an extension of ResNet architecture known for its deep structure and the connections that mitigate the vanishing gradient problem. In this project, it effectively extracts the hierarchical feature from the images, enhancing the accuracy of the disease classification. And the next one is voting decision tree. Decision tree is a classic machine learning model that partitions the data based on the most significant attribute. It is interpretable and captures the complex relationships. In the decision tree, can learn the decision rules from extracted trees to classify the plant leaf disease. And the next one is voting classifier. It combines the prediction from the gradient boosting, XGBoost, and the decision tree. The gradient boosting and XGBoost are the ensemble techniques that create the strong model from the weak ones, while the decision tree offers a baseline approach. Combining these models can provide a robust and accurate classification outcome. And the next one is user gives the input. Here we build a Flask framework as a web interface where the user can provide the input, which in this case it will provide the plant leaf image for diagnosis of the disease. And the next step is the given input is pre-processed for prediction. The user input is pre-processed, which includes transforming the input image to match the format the trained model expects. And the next one is trained model is used for the prediction. Pre-processed input is fed into the trained model, which will predict whether the input image depicts a healthy leaf or of the leaf with a disease. And the last one is final outcome is displayed. The outcome of the prediction whether the leaf is healthy or diseased is displayed to the user as the final result with the help of Flask as a web interface. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the sample folder containing of the various folders containing of images that will be used to test the performance of the model. And the static folder containing of the images, JavaScript, CSS, models, assets files within it. And the template folder containing of the HTML documents. It typically include of home, index, notebook, sign in, sign up, pages within it. And apps and py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a pickle file which contains the algorithm information and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data, performing the specific operation. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write the command that is cd space and paste this code folder path. By this, it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here redirected to this page containing of some info and the title of the project, and then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password that are need to be filled, and then click on the sign in button. Here it will redirect to this page containing of some information about it and of the choose file and upload buttons. And then click on the choose file button. Here it will redirect to this folder containing of images of leaf, and then click on the open button and then click on the upload button. Here I predicted the result as of the input image is of potato within the healthy stage. And by clicking on try again button, we redirect back to this page containing of choose file and upload button. Click on the choose file button and select the another image and by this, and then click on the open button and then click on the upload button. Here I predicted that image as containing of the pepper bell bacterial spot. In this way, we can predict whether the plant having the disease or not by using the deep and machine learning techniques. And in conclusion, in-depth investigation into the development of a plant leaf disease detection and the classification system using the both deep and the machine learning techniques. The collected dataset was pre-processed and augmented to enhance the model generalization capability. Various deep learning architectures, including the convolutional neural network, were evaluated for feature extraction, and the performance was compared with the traditional machine learning algorithm. The experimental results demonstrated that the deep learning model outperformed the traditional machine learning approach in terms of accuracy and robustness. The trained deep learning model achieved the higher accuracy in identifying the different leaf disease, indicating its potential for the practical application and agricultural settings. Overall, this research contributed to the development of an automated and efficient solution for the early detection and the classification of the plant leaf disease. The successful implementation of the deep learning model opens up the possibility for the further research and the improvement in the field of agricultural disease management.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.